Hello and welcome to section 6.2. We're going to be learning about some different properties with proportions. The first one here, you're going to notice that it starts out as 2, 3, 4. Actually, I forgot the answers. So let's go back. There's a ton of homework questions. I believe they started here. Okay, there we go. Ton of homework questions. A lot of it is algebra. Hopefully this went all right. There's just a lot you can do with proportions, actually. Then here's page 2. These are the types of questions you guys are going to see on your quiz and your test, just so you guys know. So if there's something you didn't figure out or you can't figure out from this, please make sure to ask me. And then page 3, and some of these I marked as like star problems or challenge questions, so you may not have done all of these questions here. And then one final page here. Okay, so you saw a lot of cross product in that section there. That's the property number 1. These here properties are used because basically we're going to be talking about similar figures, and you can set up a lot of different proportions, and they're all equivalent. And so the first one says it's the reciprocal property. If A over B equals C over D, then B over A equals D over C. All you're doing is you are taking the reciprocal of each of the individual ratios. And then next one is if you interchange the means of a proportion, then you form another true proportion. So the only thing you're switching here in the second one is B and C are switching. And then the last one is a really interesting one. It says if A over B equals C over D, and then you add B, or you add the denominator to the top of each one, it gives you a true one. I'm going to talk briefly about this one. A over B equals C over D. What you're really doing here is you're adding B over B. This goes way back to fractions, and then you're adding D over D. B over B is equal to 1. And D over D is equal to 1. So you're just adding 1 on both sides, basically. So it allows you to keep the equation the same. And then if you simplify this, it's A plus B divided by B. So when we're adding fractions, we just add the numerators and keep the denominator the same. And then here's C plus D divided by D. I don't really know where this is going to come into play, but it is a property, and so I do want to show it in case it does come up. Like I said, these two here are used way more than number 4 is. Number 4 is just it's kind of interesting. It's kind of unique. So they're going to give you a bunch of problems, and they're going to give you a ratio, and you're just going to fill in the numbers, and then you're going to flip them around or, do the extremes or the means one. So we have MN, which is 8 over RS, which is 10, equals NP, which is 4, over ST, which is X. It doesn't say to solve this, it just says to write other equivalents. So I'm going to start with the reciprocal one because that's kind of the easiest one. You're just going to apply the reciprocal to both. And then we'll do the means one next, where we just take the original problem and we switch the means around. And then we'll do the last one where we add the denominator. So we're going to add 10 to the left one, and we're going to add x to the right one. So you could simplify that to be 18 over 10 equals 4 plus x divided by x. And there you go. Those are all equivalent proportions. All right, find BA and BD. A lot of these questions are really, really straightforward. You're just going to plug in the numbers in and then figure out what they're looking for. So BD is this guy right here is x minus 3. Okay, so we're going to do x minus 3. And then DA is 3. And then BE, again, I'm just looking at what their values are here, 18. And then EC is 6. And then you can just solve that proportion right there. So really, there's not a lot of new stuff in this section here other than those proportions. A scale drawing is a drawing that is the same shape as the object it represents. So like blueprints, for example, is a very common form of scale drawings, or maps are really common. The scale is a ratio that describes how the dimensions in the drawings are related to the actual dimensions. Okay, so it's a ratio. So scale is a ratio how the dimensions in the drawing are related to the actual dimensions. So we have drawing over real. That is the scale. Scale is drawing over real. So the blueprint shows a scale drawing of a cell phone. The length of the antenna of the blueprint is 5 centimeters. The actual length of the antenna is 2 centimeters. What is the scale of the blueprint? So this one's blowing up. Sometimes they're shrunk like a map, and sometimes they're blowing up, like this one here to show detail. So we have the length of the antenna on the blueprint is 5. So that's the drawing. And then the actual length is 2. So what is the scale? The scale is 2.5. So all of these buttons, for example here, all these buttons are 2.5 times bigger than the actual buttons on the real phone. The scale of the map at the right is 1 inch to 26 miles. So that means 1 inch is 26 miles. Find the actual distance from Pocahontas to Algona. So we want to figure out how far it is from here to here. Now, I guess it depends if we have to take roads or not, or if we're just gonna like just go straight across if we have like a helicopter or something. Let's say that we actually take the roads here, and I put a ruler up. And this is the thing is, if you're doing this with the online textbook, your values are going to be a little different. So we'll just estimate that to be about 2.5 inches from there to there, and then we'll rotate this, if I can figure out how to do that on my smart board. I don't know. No, we can make it shorter. Oh, that looked good there. I'm going to use my computer actually, because my smart board, there we go. This is what I want to do. Okay, and then we'll measure from here to here. So that is looking like about, we'll say, about 3 centimeters. So we have about 5.5. So from there to there's 3. So we have a total of about 5.5. Oh, shoot. I think I did inches. Okay, good. It was inches. Okay. I was worried that my scale was in like centimeters to miles. So 5.5 inches. So I'm going to write this down. 1 inch gives me 26 miles. And then I'm trying to figure out how many actual miles is. So we're going to use X. And then I found if I take the roads, it's 5.5. So you do 1 times X equals 5.5 times 26. That would give you your answer. And again, it depends on how you interpret this question, because you could take a helicopter and then fly across that dotted line and be shorter. Reunion Tower, Dallas, Texas. All right, look at that. All right, cool stuff here. You buy a 3D model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. Your model is 10 inches tall, and the diameter of the dome on your scale is about 2.1 inches. What is the diameter of the actual dome? How many times as tall as your model is the actual building? Okay, so let's see. The actual building is 500. So if this here is 560 feet. I'm going to grab a calculator. And the reason why I'm grabbing a calculator is because I'm seeing inches and feet, and I don't want to deal with that. So 560 times 12, I'm just going to convert this right away to 6,720 inches. Okay, and then let's see. Your model is 10 inches tall, so the little one here is 10 inches. Okay, and the dome is this thing on the top or whatever is 2.1 inches. Okay, so let's find the scale first. The scale is looking to be the model, which is 10 inches, to the actual is 6720. So that gives me a 1 to 672 ratio there. And then so if I apply that to the dome part now, what is the diameter of the actual dome? So the actual dome is going to go on the bottom, and then 2.1 is going to go on the top. because we put the model goes on the top, the real part goes on the bottom. So 1 times x equals 2.1 times 672. I'm going to use my calculator for that. And that's going to be in inches, of course, because remember how I converted everything to inches. So if I want to get this number into feet, I'm going to divide that by 12 to get a more realistic estimate. So x equals 117.6 feet. So there you go. So this dome here, the real one, is about 117.6 feet across. That's pretty big. This thing is ginormous. All right, and then about how many times as tall as your model is the actual building? Well, this is just a simple division question. It says that we have 10 inches for the model. We have 6,720 inches. And so we already did that. We just divided that before. That's part B is 672 models. So I have to stack up 672 models to get to the height of this actual structure in Texas. All right. And there you guys go. Here's your assignment. Thank you guys for tuning in. I hope you enjoyed. Well, my smartboard's not working, so I need to use my computer.